In this video, we're going to show you how you can build this really cool 3D printed display that's compatible with TeenyMates. The recommended tools needed for this project are a computer and a USB cable that comes with the Arduino Nano, scissors, wire snips, wire strippers, needle nose pliers, a flathead screwdriver and a Phillips head screwdriver, and a really small flathead screwdriver, sandpaper in case you need to clean up your 3D prints, and a soldering iron. Additionally, you will need a 3D printer. In our case, we used an Anycubic Mega X with a build plate of 300 by 300 millimeters. If you do not have your own 3D printer, you can take the STL files to a 3D print shop where they'll print it for you. The STL files needed for this project are available for download at Colts 3D. You can search BroShark27 or you can follow the links below in the comments to find our project. Once downloaded, you will need to use a slicer to convert the STL files to G-code that your printer will understand. We use Ultimaker Cura as our slicer and it works very well. There are 5 pieces to this project: the stadium base, field, goalpost, sign, and bleachers. The supports used for the press box windows will need to be removed from the bleachers section. Go ahead and tap those out now. Additionally, if you used any supports for the stadium base, go ahead and remove those. In the video's description section below, you can find links to the supplies we used in this project. We highly recommend using Overture Professional PLA as our printer filament. We use 5 colors: green and silver, red, white, and blue. You will need a half-size solderable breadboard. 2 number 4 by 1/2 inch wood screws. An Arduino Nano, we use the Lego brand. A 5-volt power adapter and a female barrel jack. A 12mm latching push button. A 2-pin wire connector and 2 3-pin wire connectors and their corresponding hardware. 22 AWG solid core wire. And lastly, a WS2812B 5-volt LED light strip, cut into 2 sections, a 14 LED 9-inch strip and a 39 LED 25.5-inch strip. Here's the breakdown of the colors and lengths of the wires that will be needed. By following this wire schematic, your project is going to work just like ours. Here's what it will look like in the end, and we're about to break down step by step how to do it. The first thing we need to do is strip a little bit of the ends to each wire. Next, we are going to solder the Arduino Nano to our breadboard. If you choose to, you can solder every pin of the Arduino to the breadboard, but in our project, you only need the digital 2-pin, ground, voltage in, the other ground, and maybe a couple other pins for stability. Next, we're going to solder the 4-inch black wire to the negative rail of the breadboard and the 4-inch red wire to the positive rail of the breadboard. Next, we're going to take 2 of the 2-inch red wires and solder them to the latching push button. On one of those red wires, we're going to solder one of the flat wire connectors to it. Here's what it will look like when it's in the project. Next, we will solder one of the female connectors to the red 4-inch wire coming from the power rail. This will become the connection point between the push button and the power rail. Next, we will take a 2-inch black wire and we'll go from the negative rail to the ground on the Arduino. After that, we will add the 2-inch red wire from the positive rail to the voltage in. Next, we're going to work with a longer LED strip. Note that there is a direction arrow on these strips and how much of the copper ends I left when I cut them. Cutting the ends like this will help you when soldering the wire to them. We are going to use the 2 sets of 3-inch red, white, and blue wires. The red will be for the voltage in on each side, the white will be the ground, and the blue will be for the data pin in the middle. Next, take the 6-inch red, white, and blue wires and solder those to the smaller LED strip. Next, carefully feed those wires to the slot at the end of the press box. Pull the backing off the adhesive layer on the LED strip and attach it to the press box like this. Solder 3 of the female connectors to the ends of these wires. This will serve as a connection point between the LED strip in the press box and the LED strip in the stadium base. Next, we will be soldering the 5-inch red, white, and blue wires to the breadboard. We will connect the blue wire to the digital 2 pin, the red wire to the positive on the power rail, and the white wire to the negative on the power rail. Next, go ahead and solder 3 of the female pins to the ends of these 3 wires. This is going to serve as a connection between the breadboard and the LED strip in the stadium base. Next, we're going to take the longer LED strip and adhere it to the stadium base. Remember to look at the arrows for reference. The current flow is going to start at the left side of the project and work its way to the right side. There are tunnels built into the left and right side of the model. Go ahead and feed the wires through each side. Pull off the protective layer on the adhesive on the strip and attach it to the channel that goes around the field. Next, you can take the breadboard and bend the wires so that it fits nicely in the model. Add the connector housing to the beginning of the LED strip. Next, we're going to take our 2 number 4 wood screws and we're going to attach the breadboard to the model. Now you can connect the breadboard to the LED light strip. Now we can take the 3 wires from the other end of the LED light strip and press them into their plastic housing. I recommend putting the blue wire in the middle and the red and white wires on the outside. Make sure whatever wire connections you're putting together, the colors match. Next, we're going to install the latching push button. Use one side of the 2-pin wire connector to connect the latching push button to the voltage in wire on the breadboard. Now take the other red wire coming from the push button and attach it to the positive on the barrel jack and the black wire coming from the breadboard to the negative on the power jack. Finally, you can go ahead and connect the 2 LED light strips together with the 3-pin connector. Some people might recommend that you add a capacitor to the circuit. If you feel like doing that, you can add a 10 volt 100 to 1000 UF capacitor to the power rail like this. You have officially completed the hardware section of this project. If you're finding this video as helpful, don't forget to like and subscribe to our channel. Additionally, using the links to the supplies in the description below helps us bring you more content in projects like this one. To program the Arduino Nano, we're going to use Arduino IDE. To download this program, we're going to go to their official website. We're going to look at Products, scroll over to Arduino IDE, scroll down to where it says Download, and choose your operating system. For our case, we used Windows 10. Go ahead and use the USB cable provided with the Arduino Nano to plug it into your computer. When we first open Arduino IDE, we need to make sure that we have the correct board and port selected. For our case, it was Arduino Nano and COM5 on our computer. Your computer's COM port might be different depending on what you're using. Use the Tools drop-down menu to verify that we have Arduino Nano selected and the current COM port that you're plugged into. Next, you will need to install the Fast LED library. Go to Tools, Manage Libraries, type in Fast LED, and scroll down until you see the Fast LED library by Daniel Garcia. Click Install. For simplicity, we're going to be using an example code to make our project work. However, if you were going to write your own code, you would go to Include Library, scroll down to Fast LED, and include it at the top of your sketch. Before we get to the example sketch, I wanted to take a second to show you some of the really cool things these light strips can do. There are a ton of tutorials online that can help you write code if you wanted to try something different. Those are great, but to make our project easy, we're going to go to File, Examples, scroll down to where it says Fast LED, highlight that, and go over to Pacifica. A new window will open with the example code already written. This is a great code to get started with. There are just a few minor changes we need to make. The data pin that we use is number 2, change that, and the number of LEDs is 53. We need to change that. Next, let's take our max power milliamps and change that to 3200. As you can see, this example code has included the Fast LED library as well. The final step is to upload this into our Arduino. Go to the arrow near the check mark towards the top of the screen and click on it. You'll see that the sketch is compiling. Once that is finished, it will upload into our project. This takes a few seconds, so go ahead and be patient. If you made any errors or mistakes, it's going to show you right here. In our case, it's going to come back as done uploading. That means we did it correctly. Now go ahead and unplug your USB cable, and we can use the 5-volt power adapter to convert the 110 coming from our outlet to 5-volt DC, which the project runs on. The example code has a 3-second delay from when you select the push button to when the lights come on. Once they do come on, they'll run continuously until you select the switch off. Congratulations! You finished the project. We hope you and your TeenyMates enjoy this project as much as we do. If you do, don't forget to like and subscribe to our channel. Thanks again and enjoy.